Well, thank you very much for the opportunity. My name is Ulrike Passe. I'm an associate professor of architecture at the College of Design. And this is work related to a larger team funded by the Presidential Initiative here for Interdisciplinary Research at Iowa State University. And I'm going to show you part of this larger team effort, which relates to the implications of urban vegetation and trees on building energy consumption. And the topic derived from the work as an architect, where we look at the consumption of energy in buildings through what's called energy modeling, and that is a computational algorithm to understand the relationship between indoor conditions and outdoor climate and how people interact. And there is no energy model for trees, and everybody who lives in an environment with trees knows how important they are for reducing cooling consumption in our buildings. So you see here lots of data-related work. A neighborhood in Des Moines, an algorithmic computational tool to plant trees in the neighborhood, digitally plant trees, and the work here with colleagues in urban ecology to characterize trees to make 8 sample shapes of trees out of 50 species. And so that work is first and foremost related to taking climate data, which is related to sun and wind and energy and temperature around the building, into an environment where the exterior is actually changed by how the trees interact with the building through shading. And then there's another aspect of trees, because they change the temperature and the air quality around the building through what's called evapotranspiration, and they take the solar radiation through photosynthesis and they expel water. And that water then reduces the air temperature around the building and therefore also reduces the cooling consumption of our indoor environment, and also the indoor temperature if you don't have the air conditioning on. And that connects to work in the team with computational fluid dynamics. That team is led by Professor Bhaskar Ganapathy Subramanian, his PhD student, and also again Janet Thompson and her PhD student Bri Mamour. And of course, when you design in CFD, which is a computational fluid dynamics environment, very complex mathematics around the environment of the building, the challenge is to mesh the points around the building to actually provide fluid dynamics around the physical infrastructure of the building. And that needs a meshing tool, and the meshing is currently done manually, and they have developed a tool and a strategy and a workflow to automatically mesh around buildings, which then means you can change the building and the meshing follows suit automatically, and therefore also the planting of trees can show the distance between the trees into the building, how the vegetation actually influences the indoor condition. And you see some first examples of computational fluid dynamics simulation where the distance of trees to the built form immediately changes the air movement, the temperature on the building, and that now can move into the neighborhood model, which you saw at the beginning, and then actually show and ground truth the information around a whole neighborhood based on tree inventory. Thank you very much.